What's up, calculus students? Gonna make a land speed lag review. I'm going to crush this homework video right now. Okay, I'm just gonna completely crush it. We've got a bunch of different functions. Make sure you understand that there are other ways to evaluate these functions, which might help you understand their derivatives. That k's derivative, k prime, is equal to just regular f of x minus 0. Uh, g's derivative would not be just f. G would be 2 plus, kind of did this, it would be big F of x minus big F of 3, so it'd be regular F of x. H's derivative, well, H is going to be super F of x squared minus super F of negative 5. H's derivative, heads up, is going to be, because of the chain rule, regular F of x squared times 2x. J, its values are going to be regular, not super, regular f, because we go from f prime to f, regular f of x minus regular f of 0, which means j prime will equal f prime, cool, of x. All right, good. Find the x locations of the critical points of k. K, over here, here's k. Critical points when our derivative equals 0. Here is the graph of f. Here is when f equals 0. X equals negative 3, x equals 2. X equals negative 3 is a neither. X equals 2 is a max. Why? Because k prime, which equals f, and you could just literally go through the derivatives, is positive or equal to 0 from negative 5 to 2. And then k prime, which equals f, is negative from 2 to 4. You got to put that less than or equal to 0. This justifies the fact that this is a neither because we don't change signs. So we're good here. You could say k prime, which equals f, doesn't change signs. K prime, which equals f, changes from positives to negative. X locations are the points of inflection of G. G, where's G? G's here. Points of inflection of G are when G double prime, which equals F prime, changes sign. So for this guy, we needed a K prime, tells us about K, positive, positive, negative, focused on negative 3 and 2. K is increasing, increasing, decreasing. Here, we need G double prime, which equals F prime, changing signs, which means G prime, which equals F plus 2, changes direction. So if we did F plus 2, looked at when it changes direction, or when we look at G double prime, which is F slopes when it changes sign, we can see we'd have X equals negative 3 and X equals 0. Those are good. You could just say G double prime, which equals F prime, changes sign, or you could say G prime, which equals F plus 2, changes directions. Minimum value of K. Here's K. Minimum value of K. Well, let's look at K prime again. K prime is how we're going to tell when K has maxes or mins. We got positives, positives, negatives. So K is going to increase, flatten out, increase, decrease. Minimum value of K is either going to be here or here. So min of K is either at x equals negative 5 or x equals 4. How are we going to know which ones? We have to find the value of K of negative 5 and K of 4. Now, K is equal to the accumulation of F. I can't use super F because I don't have super F, so I can't use super F of X minus super F of 0. I'm going to accumulate F from 0 to the value. So I'm going to need that this area is 1, 2, 3, 4. So that's going to be 2 times 3 is 6. This is 2, base 2, height 2. This is 2 by 4. This is 4. This is -4. Cool. So if I go from 0, and you got to write this down, 0 to -5 of f, you are going to, I think it's dt, you're going to have the opposite of -5 to 0. So from -5 to 0 is 8. So my answer is -8. It's a small number. If I go 4, I'll just do 0 to 4 of f, which is going to be 0. So this is our winner. Why is that the winner? You have to say min at either x equals -5 or x equals 4, because k prime, which equals f, is greater than or equal to 0 from -5 to 2, and k prime, which equals f, is less than 0 from 2 to 4. Maximum value of g has to be at 2. Why? Because of this. We increase, flatten out, increase to 2, then we decrease. Oh, shoot. This is g, not k. Pause, rewind, go back. I feel like I need another one so I can see the graph. Okay. Wasting time. So maximum value of g. This is great. Well, I got to look at g prime. G prime is 2 plus f. I got to figure out when that's 0. Oh, do you remember? This is when we look at when f equals -2. This is our new kind of axis. And we can see that's going to be at 3. If you go down 4 over 2, you go down 2 over 1. So x equals 3. We can see that. G prime, which equals 2 plus f, is going to be greater than 0 from -5 to 3. And then g prime, which is 2 plus f, is less than 0 from 3 to 4. X equals 3 is the max location. I bet you a lot of you forgot how to do that. You could have also taken f and shifted it up 2, and when you shift f up 2, you would have seen that this is where it crosses the x-axis. Now again, like when f is bigger than -2, 2 plus f will be positive. When f is less than -2, 2 plus f will be negative. Okay, so the value, I need the value of g. So g of 3 will equal 6 plus the accumulation from -3 to 3 of f. So from -3 to, this is 6, this was 4, and now I have to figure out this is -1. So 10 minus 1 is 9. 15. No, no. Gosh, don't do that. Stop doing that. There. Okay. J. Now we're at J. J of 4, J prime of 3, J double prime of 3. Okay, well, we talked about how J of x is equal to f of x minus f of 0. We actually don't have super f. So J of 4 is equal to f of 4 minus f of 0. Oops. F of 4 is -4, f of 0 is 4. So we displace 8 is kind of like the answer there. J prime is equal to f prime. So J prime of 3 equals f prime of 3. 1, 2, 3. F prime is that slope. J double prime would equal F double prime. F double prime of 3 has to equal 0 because F does not have any concavity. Fun. What about H? H of 2 would be the integral from -5 to 4 of F. From -5 to 4, now we got to find all these areas. Oh, it's going to be 8. This is 2 plus 6 plus 4 minus 4. Now, heads up, we talked about this. H of x is super f of x squared minus super f of -5, which means h prime is going to be regular f of x squared times 2x chain rule. Minus 0, because the derivative of that is 0. So h prime of 2 is f of 4 times 4. F of 4 is -4 times 4 is -16. H double prime of 2. Ooh, H double prime of x would be a product rule. Heads up. How many of you are doing that right? Derivative of the first times the second plus the derivative of the second times the first. Great question, Mr. Master. So I need f prime of 4. We're going to assume the graph just keeps going and we can get that. I should have probably put like square root 3 or something like that. Times 8 plus 2 times f of 4, which is -4. So we're going to assume that this is -2, but if it's at a sharp point, it does not exist. They won't ask you a question like that. Great. Whatever that value is. Did you get h double prime was f prime of x squared times 2x times 2x plus 2 times f of x squared. All right, great. Now we got to break out Desmos because we got our rate in, rate out problems. Oh, I'm not going to finish this homework in time. We got fish coming in and out of lake. E is the weight that fish enter a lake. It's in fish per hour. Guess what? We have a position, we have a velocity, we have an acceleration, we have fish, how the fish are changing, and how the rate of change is changing. Cool. E and L are both derivatives. If you combine them, rate in minus rate out, you get the velocity. If you accumulate E, you'll get fish. If you accumulate L, you'll get fish. If you take the derivative of E or the derivative of L, you get fish per hour. If you're figuring out how fish are changing, you would need the value of E and L or the value of V. How many fish enter? All right, let's get this. Shout outs. I appreciate shout outs. I like it. Yeah.
Y'all have any questions about any of this?
All right, I got E, I got L, and I got V, which is E minus L. How many fish enter? We just want to accumulate the rate at which fish are entering over the 5 hours that we're talking about stuff. So I'm going to accumulate E from 0 to 5. 153.457 fish.
So I did algebra 2 freshman year, and pre-cal sophomore. Calculus junior year. Yeah,
You good?
calculus junior year, and then this year I'm done with my AP course, so it's MOD statistics.
if I want the total amount of fish at time 9, I'm gonna know that I start with a amount of fish, 500 fish, and I'm going to accumulate my E, which is my fish in. I will subtract the amount of fish that I lose, or I can just accumulate my velocity to get my total change in fish. So that's probably what I'm going to do, so long as I have written down my velocity of this situation is E of t minus L of t. You're allowed to do that. Great. So I'm going to accumulate V of t, and I have 500 plus from 0 to 9, 423.224 fish. Max amount of fish. All right, well, here is the velocity. I should be looking from just 0 to, oh, I mean, it doesn't give you a time interval, so you can just look at for forever. I'm looking at my velocity. I can see, boom, my velocity is positive, and then it hits a 0 here, then it's negative. So we're going to call that an A. So we can just say that that's definitely going to be my max. So A, which equals 6.2035. Let's shrink this.
Okay. Wow.
And is going to be the max. Because V is positive from 0 to A, and then V is negative for all values after A. So all I need to find is P of A, which is 500 plus my accumulation from 0 to A of my velocity, or of P prime. So I'm going to integrate 0 to A, my velocity, 635. It's my only candidate. I don't have to check on any other candidates. That's the winner. Is the rate of change in the number of fish of the lake increasing? Is the rate of change increasing or decreasing? Is P prime increasing or decreasing? We need to look at P double prime, which is equal to V prime at 5. So V prime at 5 can be found easily. Negative 10.722 would be the units fish per hour squared. So the rate of change in the number of fish is decreasing by 10.722 fish per squared, fish per hour per hour. So the total amount of fish increasing. Is the total amount of fish increasing or decreasing? I need to look at P prime if it's positive or negative. So I need to look at V of 1. I need E minus L. So I come in and I look at V of 1, and I get 22.428 fish per hour. Total amount of fish is increasing by 22.428 fish per hour at t equals 1. At t equals 1. These models persist. Will the lake ever run out of fish? Yes. I know that for certain because V is negative from T is for T greater than A, which means fish will decrease until the population equals 0. All right, now we spin things. Guys, it's so important to see the cylinders. It's different than what we were doing. You have to see that it's different what we're doing. First, we have to understand what it looks like when you spin.
I'll bring you the take him out.
Then you got to understand you got not H's anymore, but an R. Now, turns out R equals H in this situation. Cool. R is not always going to equal H. You're going to see R could be a bigger length. We're going to have R1. We're going to have R2. Do I need to pause because we got to go over? You want me to bring it out and you can work on it?
Like, I was doing it right. I was doing it right.
Mm-hmm. Okay. I want to sum up these cylinders. The volume of the cylinder is a pi r squared h, but this is where it's tricky. The radius is a height because the cylinder is on its side. You have to think of a cylinder on its side where the circles are on the outside. What does that look like? Like this. Horrible. 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 Here, you see that radius is a height. You see this width is the height. So it should have been like the height is a radius and the width is a height. I hope you can see that. This H is an R. This W is an H. What we end up always having is pi R squared times H. But what is now R is the key. Maybe I'm not writing it as H's anymore. Maybe I say my radius is 9 minus x squared minus 0. This is the radius length. I don't have really like a height anymore. I have a radius that I'm trying to square. I like that. So I'm going to write R. So I want to accumulate my pi r squared h's from 0 to 3. I'm going to use that in today's lesson. And I can use Desmos to get my answer. What if I spin around the y-axis? Well, if I spin around the y-axis, it goes here. What should I be using? A horizontal rectangle that gets spun to create a cylinder. Now the cylinder will look like the cylinders we are used to talking about, where the radius is now a x distance and the height is a very small y distance. I'm not even going to do this. I'm just saying that's R, that's W. Or this is H, this is R, this is R, this is H. I want pi r squared H, but it's pi r squared H is dy. What is R in this case? R in this case is a x distance. It's an x distance from an x equals left to an x equals right. You could say R equals W if you'd like. You could say W is root 9 minus y. You solve for W. You can just say R is root 9 minus y. I'm going to go with R as root 9 minus y in this situation. Know that I sum them up from my bottom to a top when x is 0, y is 9. Use your calculator to get those answers. Spun around the x-axis. I'm just going to do the setup. I'm not going to get the answers. It should be easy to type this in. I'll do this one. Spun around the x-axis, no calculator. Okay, here are my cylinders with radiuses. Hey, James! You doing all right? Good. My radius is this x, this y equals x distance. Y equals root x. I want to do a sum of those pi r squared h's, which is pi r squared dx. From 0 to 9. I need r squared. R squared is x. I need the antiderivative of r squared. I'm just going to write the antiderivative of r squared equals 1/2 x squared. So I need the antiderivative at 9, which is 81 halves, minus the antiderivative of 0. This is going to be my answer, pi times 81/2. And here comes the first question that is going to challenge us. This is the question that everybody needs to star and heads up, because if you're making any mistakes, here's where you're making them. You could either treat this as two different sets of cylinders, which are a cylinder that is going all the way to the outside, and then cylinders that go into the inside. Here are my cylinders going all the way to the outside, and you got to draw this with radiuses here. And then a second set of cylinders going to the inside. You could do the volume of the object minus the volume of the hole. Or what you could do is find the volume of what's called a washer. Now, the washer is where we all make mistakes, because we're like, well, if I take this like length and spin it, I will get like its volume. And if I add up all of these washers, which is just like a cylinder with a hole in it, we'll call that a washer, then we're good. But the key is people always think that the washer is pi w squared dy. This is wrong. And it comes from here. We have a pi bigger radius squared dy minus a pi smaller radius squared dy. If I factor out the pi, factor out the dy, we realize that the volume of the washer is pi outer radius squared minus inner radius squared dy. This can be done, but what people make mistakes for is they think it's a pi w squared. It's not. It's pi r squared. R might equal W sometimes, R might equal H sometimes, but not always. So let me just show you what it looks like. I'll sum up from a y equals bottom to a y equals top. You got to make sure you can get that. That's y equals 3. How do I get that? Come on, x equals 9, x equals pi, bigger radius squared. My bigger radius is the radius of this black one, the radius of this black, and you can see it's always going to go x equals 9 minus x equals 0. The bigger radius is always 9. What is the smaller radius? Well, the red radiuses here are always going to be going to x equals y squared. X equals y squared minus x equals 0. So sum up those smaller radiuses squared. You type this into Desmos, you're good. Make sure you have big R's 9, little r's y squared. If you wanted to do this all at once, you could go 0 to 3 pi bigger radius squared minus smaller radius squared dy in this situation. It's not w squared. It's not right minus left squared. It's not. It's not. W equals 9 minus y squared. It's not sum up w pi w squareds. It's not correct. Not correct. We spin this around the x-axis. Outer cylinders radius, big radius, root x minus 1 minus 0, inner cylinders, 1. We need to go from x equals 2 to x equals 10. Sum up from x equals 2 to x equals 10. Pi outer radius squareds minus inner radius squareds. Times x. X is the height. This is a small x distance. You can do it separately. You can do it together. Spin around the y-axis. Pops over here. Let me write that down there. Setting a land speed record, mostly because I'm not actually plugging it into my calculator, but like if we can't plug in our calculator, then we got a problem. Makes sense to use horizontal rectangles being sun to create horizontal cylinders. Now, notice how said cylinders or said washer is not going to be the correct formula. If you do pi w squared, you don't get the outer squared minus the inner squared. So that's not correct. If you want to draw the washer, you can, but I wouldn't because I would just remember I got bigger radiuses and I have smaller radiuses. My bigger radiuses are an x equals distance. It's an x equals 10 minus, where does it go to? X equals 0. My smaller radiuses go to this dot here. My smaller radiuses go to this dot here. My smaller radiuses are an x equals y squared plus 1 minus an x equals 0. You can do pi. We're going to go from 1 to 3. This is y equals 1. This is y equals 3. You need to do that job. Pi 1 to 3, my outer radius squareds minus my inner radius squareds, or pi 1 to 3, outer radius is squareds minus pi 1 to 3, smaller radius is squared. Yeah, I'm going to use big R and little r. I'm not going to use f of x, g of x. You got to make sure you know it's an x distance or a y distance. It is a width, but it's like an x distance. I don't want to call it a width times height. It's different. It's different. It's radiuses, so it's different. And that's especially true when we spin around y equals 5. Here's y equals 5. If I spin this around y equals 5, what happens? Well, this gets reflected up here. You have to draw the reflection. You have to draw the cylinders. How I need all of this. That would be a radius. And then I need these. That would be a radius. What is the black radius? The outer radius, the bigger radius, which is this outside distance, 5 minus 1, which is 4. What is the red radius? The red radius. God bless me. It's a smaller radius. The smaller radius is 5. Y equals 5 minus y equals 5 root x. 5 minus root x minus 1. I'm going to sum up these vertical things from an x equals left to an x equals right. This is x equals 2 to x equals 10. However you want to do it, you good? If you want to do that, minus that, or if you want to do outer radiuses minus inner radiuses squared. Okay. Turns out the height is equal to the width, but really we're just going to say they're radiuses, so that's different. It's not rectangles. Yes, they are rectangles kind of being spun, which create radiuses. X equals 11 is over here. All right, well, if we spin it over here, you gotta see the visualization. We could see outer radiuses. Now, what would be my outer radius? Well, I can see here's the middle, here's the left, right? That would be my big R. What would be an expression of my big R? Well, it's an X distance. It's X equals 10 minus, solve this by squaring it and adding 1, minus X equals Y squared plus 1. What is my inner R? Well, no matter where we are, it's always, oops, that's X equals 11. My inner R is always X equals 11 minus X equals 10, or my inner R is always 1. Sum up. Let's do it once. My outer radius is squared minus my inner radius is squared. It's not times dx, it's times dy. And I'm just rewriting r every single time. It is from a y equals bottom to a y equals top. If x is 10, this is 3. Actually use Desmos here. This homework could be easy if you really know what you're doing. If you don't know what you're doing, yeah, I can see how it's tough. Okay, so I'm going to call this B, and we're going to call this D. I feel like we did this one before. So we got x equals 0, x equals B. We got y equals 1, and y equals D. Okay, if I spin around the x-axis, it ends up down here. I got outer radiuses, which always are this y distance. This bigger radius is going to be the 2x plus 1, y equals 2x plus 1 minus y equals 0. Inner radiuses, e to the x over 2 minus 0. Pi, big R squared minus pi, small r squared, or pi, bigger R squared minus smaller R squareds. They have a very skinny height. Like that's a dx right there. You're going to go from x equals 0 to x equals b. You want to see how you type it in? Here's how you do it. You'd say r equals 2x, big R equals 2x plus 1. I hope this works actually because I haven't done it yet. E to the x over 2. I'm sure it works. Let's see. Pi, integral 0 to b, parentheses, big R squared minus small r squared dx. Bam! Just make sure we get two different values if I do small r versus big R. Yes! So sick! I'm telling you, man. Game changing. Game changing. Love it. 246.260. Spun around the y-axis. Okay, we're coming over here. Coming over here. Outer radiuses. They're not widths anymore. They're radiuses. It's not rectangles. They're cylinders. The cylinders that I'm drawing. As this big radius goes all the way to this x equals. Well, if y equals e to the x over 2, log y times 2 is x. My big radiuses are 2 log y minus x equals 0. What are my smaller radiuses that I need to subtract from my bigger radiuses? Well, if we have y equals 2x plus 1, y minus 1 over 2 is equal to x. My smaller radiuses in red will be x equals y minus 1 over 2 minus x equals 0. This is x equals 0. So we are going to go from 1 to d to sum up these horizontal things. Outer radius squared minus inner radius squared, or two separate integrals. This is a skinny y distance. That is that small height. So I'm going to go from 1 to d. I'm going to change big R to 2 log y. I'm going to change little r to y minus 1 over 2. And we're going to notice that I can't go from 0 to b. I have to go from 1 to d. And I changed it from dx to dy. Gosh, what a great thing. 123.424. Going around y equals 11. I'm just going to set it up. I'm not going to type it in because it's the same. Outer radiuses, big radiuses. They're not heights anymore. They are big radiuses. This is y equals 11. My big radius here, this length, is a y equals top minus a y equals bottom. Small radiuses is a y equals top minus a y equals bottom. 0 to b by outer radius squared minus inner radius squared. Dx, not dy. Spun around x equals 5. Here's x equals 5. The reflection comes over here. I could have done this video tomorrow, to be honest, but it's good stuff. Outer cylinders whose radius is here to here. Must be, x equals right minus an x equals left. Inner radiuses. X equals right. It's really x equals middle minus x equals left. Sum up those from a bottom to a top. You can have pi r squared minus pi r squared h minus pi r squared h, or you could have pi r squared minus r squared. It's a good question because you have to see that when you spin it around y equals 6, you have a solid. There's no hole. You just have one sets of radiuses. They're big R's. It's a top minus bottom. When y is 6, x has to be 9. Sum up my pi r squareds dx from 0 to 9. But if it's x equals 9, we have a hole. Outer radiuses, look at this guy. X equals 9 minus x equals 0. My big radius is 9. X equals 9 minus, this will be y over 2 squared. So y squared over 4. So my smaller radiuses are 9 minus y squared over 4. Gonna sum up from a y equals bottom to a y equals top. My outer radiuses minus inner radiuses times pi. Notice how these are not the same as semicircle. Why is this one harder? Because my outer radiuses go all the way from 0 to 4, but my inner radiuses are going to go from 2 to 4. This has to be kind of split up. Okay. That's it. I did it. Peace.